If I told you there was this single, entirely free molecule that could, physically alter the thickness of your child's arterial walls like 30 years into the future, you would probably assume we were talking about some kind of futuristic gene therapy.
Oh, yeah,
Yeah.
absolutely. Or, I mean, if I said there was a compound that could literally determine whether your incredibly expensive chronic illness medication actually works or just fails completely, anyone would want to know where to buy it.
Exactly. But we aren't talking about a pharmaceutical breakthrough today. We are talking about something you manufacture yourself um, every single time you step outside on a sunny day.
Which is pretty incredible when you think about it.
It really is. So welcome to the deep dive. Today we are taking a massive stack of nutritional research, clinical trials, and these huge population studies, and we're aiming it all at one of the most misunderstood topics in human health, vitamin D.
Yeah, and the misunderstanding really starts at the name itself, doesn't it?
Oh, for sure.
Because most of us are taught from a very young age to view it simply as, like, the bone vitamin. It's the cartoon sunshine on the side of the milk carton.
Right, exactly.
But that classification is just fundamentally inadequate for what this molecule actually does inside the human body.
So our mission today is to completely dismantle that simplistic idea. We're going to reveal how vitamin D is actually this crucial full-body regulatory hormone.
Yeah, because we are talking about the architectural integrity of your skeletal system, yes. But we're also looking at your cognitive function, your gut microbiome.
Your mental health.
Exactly, your mental health, and even your baseline risk for severe chronic diseases. It essentially acts as a master switchboard for cellular function.
Wow, a master switchboard.
Yeah, and when you view it through the lens of endocrinology rather than just, basic nutrition, you start to see why a deficiency doesn't just cause weak bones. I mean, it causes systemic chaos.
Systemic chaos. That is a heavy phrase. And I want to speak directly to you listening to this right now, because maybe you're proactively trying to optimize your longevity.
Right.
Or maybe you're incredibly frustrated because you feel exhausted all day, every day, regardless of how many hours you sleep. Or maybe you're just wildly curious about how the machinery of your own body operates.
Whatever brought you here, we're going to cut through the noise, bypass all the medical jargon, and figure out what is actually happening beneath your skin.
So to really grasp the sheer scale of what this molecule does, I feel like we have to start at the foundational level.
We do. We need to define what vitamin D actually is, chemically speaking, and kind of trace how it enters our biological systems.
Okay, let's unpack this. Let's start with the biochemical definition. At its core, vitamin D is a fat-soluble vitamin.
Yes, and that hyphenated term, fat-soluble, that is the key to the entire ignition sequence.
Wait, how so?
Well, it means that for your body to absorb this nutrient, transport it, and store it in your tissues, it absolutely requires the presence of dietary fat.
So if you swallow a bare vitamin D supplement on an empty stomach with just like a glass of black coffee?
You are essentially wasting your money.
Oh, wow, really?
Yeah, because the human digestive tract needs a lipid carrier. Without fat acting as a vehicle to pull it across the intestinal wall and into the bloodstream, the vitamin just passes right through your system completely unutilized.
It's like trying to wash away cooking oil with plain water. It just beads up and sits there.
That is a perfect analogy.
You need soap to bind to the oil, and in this case, you need dietary fat to bind to the vitamin. But this is where vitamin D breaks all the rules of what we traditionally consider a vitamin, right?
Oh, absolutely. I mean, if you want vitamin C, you have to go find a citrus fruit.
Right.
If you want B vitamins, you have to forage for leafy greens or meat. You have to acquire them from your external environment.
But vitamin D is the sunshine vitamin. And that isn't just, a clever marketing slogan. The human body is equipped with its own highly sophisticated built-in manufacturing plant.
We literally make it ourselves.
Which is wild. How does that actually work?
The mechanism is just a marvel of evolutionary biology. When your bare skin is exposed to direct ultraviolet B rays from sunlight, it interacts with a specific type of cholesterol that's present in your epidermis.
Right, cholesterol.
Yeah, that solar radiation physically breaks open a chemical ring in the cholesterol molecule, which creates a previtamin. But the skin is really just the first stop on the assembly line.
So it's just raw material at that point.
Exactly. That raw previtamin enters the bloodstream and travels to the liver.
Okay.
And there it gets converted into a storage form called calcidiol. But it's still not ready to be used.
It has to go somewhere else.
It has to make one final trip to the kidneys, where it undergoes a final chemical transformation into calcitriol. And that is the active potent steroid hormone that actually goes out and unlocks the cellular functions all over your body.
Skin to liver to kidneys, just a perfectly engineered, free biological factory, which honestly leads to a glaring paradoxical question for me. If we have this internal factory, and the catalyst to turn it on, sunlight, is shining down on the planet every single day, why do the clinical demographics show that a majority of men and women in the U.S. have low levels?
It's a great question.
I mean, we're failing to manufacture something that is entirely free.
Well, the truth is, we have engineered an environment that is fundamentally hostile to our own biology. We've placed these massive roadblocks in front of our own factories.
Like what kind of roadblocks?
The most obvious one is geography. The angle of the sun matters immensely. If you live in a northern climate, say basically north of Atlanta or Los Angeles,
Okay.
for several months out of the year, the sun sits so low in the sky that the atmosphere filters out almost all of the crucial UVB rays.
So it just doesn't reach us.
Right. You could stand completely naked in a snowbank in Maine in January
Right.
at high noon, and your skin simply will not produce vitamin D. The solar trigger just isn't reaching you.
The factory literally shuts down for the winter.
It does. But even in the summer, we actively avoid the trigger. Human beings evolved hunting, foraging, and living outdoors.
Yeah, and today we wait up in a climate-controlled house, commute in a tinted car, work for 8 hours inside a corporate office, and exercise inside a fluorescent-lit gym.
We are a chronically indoor species.
We really are.
And on the rare occasions we do spend prolonged time in direct sunlight, we apply sunscreen. Now, dermatologists and oncologists are absolutely aligned on this point.
Right, sunscreen is a critical, non-negotiable tool for preventing cumulative DNA damage in the skin.
Exactly, and mitigating the risk of melanoma and other skin cancers.
So we're definitely not suggesting anyone throw away their SPF here.
Not at all. But we do have to acknowledge the biological trade-off. Sunscreen works by absorbing or reflecting UV radiation. An SPF of just 30 blocks roughly 97% of UVB rays.
Wow, 97%.
Yeah, so by successfully protecting your skin cells from mutation, you are simultaneously blocking the exact wavelength of light required to synthesize vitamin D.
It's a brutal catch-22. You prevent the sunburn, but you basically starve the hormonal assembly line.
Exactly.
And the ripple effects of that starvation are staggering. We aren't just talking about a slight dip in bone density here.
No, not at all.
The overview of its systemic role paints a picture of a nutrient that is desperately trying to keep the body's major departments from collapsing.
It really operates as a vital component of the immune system's threat detection network. But beyond fighting off acute infections, the medical data identifies healthy vitamin D levels as a preventative factor against a formidable list of malignancies.
Like cancers.
Yes, the literature links sufficient levels to lower risks of breast, colorectal, skin, pancreatic, and prostate cancers.
That is a heavy list. Add in its role in regulating high blood pressure, mitigating clinical depression, and heavily influencing metabolic obesity, and it becomes crystal clear why falling short is so dangerous. So because our internal factories are so often shut down by modern life, we have to look for external workarounds, which introduces the different types of vitamin D you're going to encounter if you walk down the supplement aisle.
Right. The dietary forms found in the research are basically bifurcated into two main categories. You will see vitamin D2, which is scientifically known as ergocalciferol,
Ergocalciferol, okay.
and vitamin D3, known as cholecalciferol.
Ergocalciferol and cholecalciferol. For the sake of everyone's sanity, let's just stick to D2 and D3.
Good idea.
What is the actual difference between these two molecules?
It comes down to their origin and how our bodies interface with them. Vitamin D2 is derived entirely from plant sources and fungi. When mushrooms are exposed to UV light, they synthesize D2.
Oh, that's interesting. And D3.
Vitamin D3, on the other hand, is found in animal products, and crucially, it is the exact same chemical structure that our own skin produces in response to sunlight.
So if I'm looking at this from a biological perspective, I shouldn't view them as equal options, right? Like, think of it like a computer operating system. If the human body runs on a specific software language, vitamin D3 is the native code. It's perfectly formatted.
I like that analogy.
The body instantly recognizes it, integrates it, and executes the program. But vitamin D2 is like a program written for a completely different operating system. It still holds data, but your body has to run it through this clunky translation software just to read it.
That is a highly accurate way to visualize it because D2 requires that extra metabolic translation it is far less efficient.
Makes sense.
The clinical literature demonstrates quite clearly that vitamin D3 is vastly superior at actually raising and maintaining the serum levels of vitamin D in the human bloodstream.
Meaning D3 actually moves the needle on your blood tests. It's the premium fuel. So when this native code successfully boots up in the body, what physiological machinery is it actually powering?
We have to begin with the skeletal system, because that is where vitamin D exerts its most famous and perhaps most mechanical influence.
Right, the bone vitamin.
Exactly.
Yeah.
Its primary job in the realm of bone health is the strict regulation and absorption of two minerals, calcium and phosphorus.
The actual structural materials of the skeleton. But let me challenge the premise here for a second.
Okay, go ahead.
Let's say a person's vitamin D levels are absolutely tanked, but they are consuming a massive amount of dairy. They're drinking a gallon of whole milk a day, eating cheese, taking calcium supplements.
Okay.
They are flooding their digestive tract with calcium. Will their bones still degrade?
They will degrade significantly.
Wait, really? Even with all that calcium?
Yes. The sheer volume of calcium you ingest is totally irrelevant if the transport mechanism is broken.
Wow.
Think of the lining of your intestines as a locked door. The calcium is sitting in your gut, knocking on the door, trying to get into the bloodstream to be delivered to the skeleton. Vitamin D is the physical key that unlocks the cellular channels in the intestinal wall.
So without the hormone, the door just stays shut.
Completely shut. The calcium simply continues down the digestive tract and is excreted as waste. You can be hyper-nourished with dietary calcium while your skeleton is simultaneously starving to death.
That is wild.
And it gets worse. When the blood doesn't get enough calcium from the gut, the body panics. It needs calcium for your heart to beat and your nerves to fire.
Right.
So it releases a different hormone to literally mine the calcium out of your existing bones to keep the blood levels stable.
Oh my God. It cannibalizes its own architecture just to keep the heart pumping. That is a terrifying biological failsafe.
Which is exactly why the lock and key function of vitamin D is so paramount.
Uh-huh.
But the functions extend far beyond the skeletal matrix. Moving into the muscular system, the presence of this hormone is essential for the actual contractile strength of muscle fibers.
So it isn't just about the bones providing a rigid frame for the muscles to pull against. The muscle tissue itself requires the hormone to generate force.
Precisely. A hallmark symptom of clinical deficiency is a profound generalized muscle weakness. The fibers simply cannot execute their mechanical function optimally without the signaling provided by vitamin D.
Wow.
And then we move to the immune system. We mentioned it acts as a preventative factor against specific cancers, but it also manages daily threats.
It's heavily involved in the activation of T cells, right? The immune system's frontline soldiers.
Yes. When a macrophage, which is a type of white blood cell, encounters a pathogen, it actually releases a localized form of vitamin D to signal and arm the surrounding T cells.
Okay, and if you're deficient?
If the body is deficient, the T cells remain completely dormant, they are blind to the infection, it compromises the entire localized defense response.
It's like having an army standing around, but the radio network is down, so no one receives the order to attack.
Exactly.
And speaking of networks, the regulatory functions in the brain and metabolic systems are just immense.
This is where we cross into neurology and cardiology. The literature strongly correlates vitamin D levels with the regulation of high blood pressure, the physical manifestations of major depression, and the complex hormonal cascading of obesity.
That is a lot of ground to cover.
It actually crosses the blood-brain barrier and binds to receptors in areas of the brain that regulate mood and behavior.
So, knowing that this single molecule builds our bones, arms our immune system, and wires our mood, we need to know where to find it. Because sitting indoors all day clearly isn't working. Where can you naturally stock up on this nutrient?
The absolute gold standard remains natural sunlight. Exposing large areas of the skin like the arms, legs, and back to midday sun for roughly 10 to 30 minutes, depending on skin type, is the most biologically efficient way to fill the tank.
But there is a very dark, very dangerous temptation here, especially for people living through brutal, dark winters in northern latitudes.
I know exactly what you're going to say.
Right. They think, I'll just bypass the winter by going to an indoor tanning salon. I'll get the UV rays synthetically.
Well, the medical consensus issues a hard stop on that logic. While it is technically true that a tanning bed emitting UVB radiation will trigger the skin to manufacture vitamin D, the cost is just catastrophic.
Because of the damage to the skin.
Right. Tanning equipment bombards the skin with a highly concentrated, unnatural spectrum of UV rays that heavily accelerates DNA mutation.
The skin cancer risk.
Exactly.
Yeah.
The exponential increase in the risk of melanoma and non-melanoma skin cancers makes indoor tanning medically indefensible. It must be strictly avoided. You are essentially trading a manageable vitamin deficiency for a lethal malignancy.
So the tanning bed is totally out. If it's the dead of winter in Chicago or you work a graveyard shift, we have to pivot to food sources. And looking at the data, if you want this native software code, you really need to look to the ocean.
The marine food web is uniquely positioned to deliver highly bioavailable vitamin D.
The rankings and the sources are very clear on this. Salmon is classified as an excellent source. It sits at the top of the hierarchy.
It does.
Dropping down a tier to very good, we find sardines. And then in the good category, we have tuna and eggs. And there is a very obvious unifying biological trait among all those foods.
They are entirely wrapped in lipids. Salmon, sardines, tuna, and egg yolks are rich in natural fats.
Which brings us all the way back to the definition. Fat soluble. Nature didn't put this vital hormone in a dry cracker. It packaged it inside fatty fish and egg yolk so that the moment you digest it, your body already has the exact lipid vehicle it needs to absorb it through the intestinal wall.
It is a brilliant all-in-one delivery system.
It really is.
And for individuals following a strict plant-based diet who do not consume marine life or eggs, the options are severely limited. But there is one notable non-animal source that reaches the good threshold.
Shiitake mushrooms.
Yes. The fungi producing the D2 we talked about earlier. It's the translated software, but it's much better than nothing.
However, the reality of modern Western diets is that most people simply are not eating enough salmon or shiitake mushrooms on a daily basis to maintain functional hormone levels.
Which necessitates public health interventions. This is exactly why we rely heavily on fortified foods. A massive percentage of the dietary vitamin D consumed in developed nations is artificially added to staple products. Milk is the classic example.
Literally adding the key directly to the calcium lock.
Exactly. You are providing the mineral and the hormone required to absorb it in a single glass. You will also frequently find it fortified in breakfast cereals, oatmeal, and orange juices.
But even with a diet full of fortified cereal and occasional salmon dinners, nature and the grocery store often fall short of the metabolic demand. This is the point where we introduce direct supplementation.
When environmental and dietary intake is insufficient, targeted supplements are highly effective. They are widely available over-the-counter in soft gels, capsules, tablets, and liquid drops.
Usually ranging from doses of 50 to 1,000 IU, right?
Correct.
Let's clarify that measurement real quick. IU stands for international units. It's the standardized metric for measuring the biological activity of vitamins.
And for people with extreme gastrointestinal disorders, like individuals who physically cannot digest fats and therefore cannot process an oral soft gel, medical providers can prescribe injectable vitamin D.
So they just bypass the gut completely.
Exactly. The intramuscular injection bypasses the compromised digestive tract entirely, delivering the hormone straight into the tissue to be absorbed into the bloodstream. It's a critical lifeline for patients with malabsorption diseases.
Okay, so we have the sun, the fish, the fortified milk, and the supplements. We have the tools. Now let's look at the actual blueprint. How much of this do we need to be taking in every single day?
Well, the National Institutes of Health, through their Office of Dietary Supplements, gives us a very rigid, age-based roadmap.
Let's break that down.
The baseline recommendations are remarkably consistent across the majority of the human lifespan. For infants from birth to 12 months, the recommendation is 400 IU per day.
400 IUs just to start building that foundational skeleton. But then we hit a massive plateau, don't we?
We do. From a toddler at age 1 all the way through adolescence, adulthood, and up to age 70, the recommended daily intake locks in at 600 IU per day.
So a 15-year-old going through a massive growth spurt, a 35-year-old office worker, and a 65-year-old preparing for retirement all share that exact same 600 IU target.
Yes, and this target remains at 600 IU for pregnant and breastfeeding women as well.
But once an individual crosses the threshold of 70 years old, the requirement elevates to 800 IUs per day.
Right.
And the mechanism behind that increase makes perfect sense. As you age, your skin becomes thinner. The factory equipment is degrading. It takes more raw material to produce the same output, so you need a larger external supply.
The cutaneous synthesis of the vitamin becomes severely blunted.
Now, those are the baseline goals just to keep the lights on, but the NIH also outlines the upper safe limits. This is the red line, the absolute ceiling before you risk biological damage. And the numbers here require some context.
For infants, the absolute upper limit is 1,000 to 1,500 IUs per day,
which is roughly triple their daily requirement.
For children between the ages of 1 and 8, The ceiling rises to 2,500 to 3,000 IU. And for anyone 9 years and older, from a fourth grader all the way to a centenarian, the maximum tolerable upper limit is 4,000 IUs a day.
Okay, I have to stop here and push back on these numbers because there is a glaring biological contradiction.
What's that?
We just established that the human body can manufacture tens of thousands of IU in a single afternoon at the beach. You can generate 15,000 to 20,000 IU internally just by walking around outside in the summer.
That's true.
So why is my body totally fine producing 20,000 IU naturally, but if I swallow a 5,000 IU pill, I am suddenly crossing a dangerous toxic threshold?
It is a brilliant question, and the answer really lies in the brilliance of the skin's self-regulating machinery.
Okay.
When your skin manufactures vitamin D from sunlight, it possesses an automatic degradation pathway. Once the blood levels reach an optimal state, the excess pre-vitamin D produced in the skin is automatically destroyed by the sunlight itself. The factory turns itself off.
Wow, you physically cannot overdose from the sun.
The sun provides the fuel, but also hits the brakes.
That is amazing.
Precisely. But when you swallow an oral supplement, you're bypassing that entire regulatory checkpoint. The digestive tract does not have a shut-off valve. It blindly absorbs whatever you force into it.
Oh,
If you swallow 10,000 IU every day, the gut will absorb it, the liver will process it, and it will flood the bloodstream, overwhelming the system.
So the 4,000 IU upper limit isn't about what the body can handle in total. It's about what the gut can safely dump into the system without causing an overload.
Exactly.
The sources carry a strict warning about this. You can easily walk into a pharmacy and buy pills marketed at 5,000 or 10,000 IU, but those hyperdoses are designed for acute medical correction under a doctor's supervision, not just like daily maintenance. Do not play pharmacist with your own hormones.
Exceeding that 4,000 IU limit independently is a recipe for toxicity, which we will definitely detail shortly.
But toxicity is rare. The far more common, devastating reality is falling short of the 600 IU minimum. Let's examine who is actually falling behind, because the causes of deficiency are woven into our environment, our age, and our very genetics.
We've covered the environmental trap of northern climates and the physiological reality of aging skin. We also know statistically that younger demographics tend to maintain better levels than older populations, and males generally register higher levels than females.
But there is a massive biological factor that dictates exactly how efficiently your personal factory operates, and it has to do with the physical color of your skin.
Right. Melanin is the pigment responsible for skin color. Biologically, melanin acts as a brilliant, natural sunscreen. It is an evolutionary adaptation designed to protect the deeper layers of the skin from the destructive effects of ultraviolet radiation near the equator.
It's an internal shield.
Exactly.
Okay.
However, because it is so incredibly effective at absorbing and scattering those UV rays, it simultaneously blocks the very radiation required to synthesize vitamin D.
Oh.
The darker the skin, the more UVB is blocked, and the less vitamin D the skin can manufacture in a given amount of time.
So the very mechanism that protects you from skin cancer actively starves your hormonal factory.
It is a major evolutionary trade-off. The clinical data reflects this clearly. Individuals with darker skin tones absorb significantly less sunlight for this metabolic process. Consequently, the demographics show that non-Hispanic Black populations tend to present with the lowest average levels of serum vitamin D, while non-Hispanic white populations tend to have the highest.
That is a critical piece of biological reality. If you have higher levels of melanin, you just cannot rely on casual sun exposure to maintain your levels, especially if you live in a temperate climate. You have to aggressively manage your dietary and supplemental intake.
You really do.
Now, moving past the skin, let's look at body composition. Obesity is highlighted as a massive primary driver of deficiency, and the mechanics of why are fascinating. I want to bring back the sponge analogy.
It perfectly illustrates the pharmacokinetics at play.
Because vitamin D is fat-soluble, it has a deep chemical affinity for lipid tissues. It loves fat. So when a person is obese and carries a high volume of adipose tissue body fat, that tissue acts like an enormous internal sponge.
Right.
As the vitamin D enters the body, whether synthesized from the sun or absorbed from a salmon fillet, it circulates toward the fat cells.
And the adipose tissue chemically binds to it. It actually sequesters the hormone.
The vitamin literally gets trapped inside the fat. So technically, the molecule is inside the patient's body, but because it is locked away inside the adipose tissue, it cannot circulate in the bloodstream to reach the bones, the brain, or the immune system.
The total body store of the vitamin might be completely normal, but the bioavailable serum level, The amount actually free to do the work plummets.
You are starving in the middle of a grocery store. And this same deprivation happens in severe gastrointestinal disorders like Crohn's disease or celiac disease.
Those are malabsorption conditions. They physically inflame and damage the delicate lining of the intestinal tract, destroying the body's ability to emulsify and absorb dietary fats.
And as we established at the very beginning, if you can't absorb fat, you can't absorb a fat-soluble vitamin, it's a closed door.
The nutrient simply washes right out of the system.
But the roadblocks aren't just biological. We also have to look at the structural inequalities of society. The sources included a highly revealing 2017 study out of France looking at this exact intersection.
They examined a cohort of 564 severely and morbidly obese adult patients. The researchers were looking at the known link between high adipose tissue and low vitamin D. But they uncovered an additional, deeply concerning layer.
How was it?
They found that low socioeconomic status acted as an entirely independent risk factor for severe deficiency within this group.
Meaning that if you took two patients with the exact same body mass index, the patient with fewer financial resources was at a statistically higher risk of having utterly depleted vitamin D levels.
Exactly.
It proves that this isn't just about how your cells work. It's about whether you have access to nutrient-dense foods, the free time to recreate outdoors in safe environments, and the means to afford proactive medical care.
It highlights socioeconomically disadvantaged populations as a highly vulnerable group requiring specific public health targeting.
So if you fall into any of these overlapping categories, you live in a snowy climate, you have dark skin, you are carrying excess weight, you have a gut disorder, what are the actual red flags? What is the warning system your body triggers when the tank runs dry?
The clinical presentation of a deficiency is notoriously deceptive, primarily because it begins with what we call a silent face.
The symptoms are infuriatingly vague.
Very vague. In the early to moderate stages of depletion, a patient will rarely present with a localized acute problem. Instead, they will report generalized fatigue, a subtle depressive shift in mood, or a mild, unexplainable heaviness or weakness in their muscles.
It's the kind of baseline exhaustion that a modern adult just chalks up to stress, a bad mattress, or working too many hours. You just assume you are getting older.
Right.
You don't naturally conclude, my endocrine system is starving for a steroid hormone.
Which is exactly why it goes undiagnosed for so long. But if the depletion is allowed to progress into a severe chronic state, the structural integrity of the body begins to fail. In fully grown adults, this manifests as a condition called osteomalacia.
Break down the pathology of osteomalacia for us.
Well, osteo refers to the bone, and malacia translates to softening. Because the body lacks the vitamin D required to absorb calcium from the gut, it resorts to that biological failsafe we discussed earlier.
Mining the bone.
It begins stripping calcium out of the existing skeletal matrix to keep the blood levels viable. Over time, the bones physically demineralize. They lose their density and rigidity.
The architectural columns of the body are literally turning to chalk.
This results in profound, deep-seated bone pain, often felt in the lower back, pelvis, and legs, accompanied by intense muscle weakness.
That is what happens to a fully formed adult skeleton. What happens when this severe depletion strikes a child whose bones are actively trying to lengthen and grow?
In children, the manifestation is called rickets. It's a catastrophic developmental failure.
That sounds awful.
Because the rapidly growing cartilage never receives the calcium required to calcify and harden into true bone, the skeletal structure remains soft and pliable. When the child begins to stand and walk, the sheer mechanical weight of their own body causes their leg bones to physically bend and bow outward.
Permanent structural deformity caused by a lack of sunlight and nutrition.
And the sources emphasize a critical vulnerability here: breastfed infants. Human breast milk is a miraculous nutritional source, but it is inherently poor in vitamin D, especially if the mother is herself deficient.
That's a huge blind spot.
It creates a dangerous blind spot, which is why pediatricians mandate that exclusively breastfed infants receive proactive liquid supplementation.
Drops of vitamin D directly into the mouth to ensure the bones actually harden. So what does this all mean? We've walked through the mechanics, we've established the baseline, now we are crossing the threshold into the absolute core of this deep dive.
We are moving from the foundational physiology right into the clinical data.
We are about to unpack a massive stack of peer-reviewed clinical trials that investigated exactly what happens across different bodily systems when vitamin D levels collapse. We are going to explore the brain, the gut, the cardiovascular system, and fetal development.
What's fascinating here is the sheer scope of the research. It is what makes this molecule so unique. It is not confined to a single medical discipline.
Let's start at the top with mental and cognitive health. And let's return to that vague, silent symptom we just mentioned, fatigue. The sources provide a striking 2016 study from Switzerland published in the journal Medicine.
Right.
The researchers gathered 120 healthy adults. These were predominantly young professionals, mostly Caucasian, living in an advanced, wealthy society. Every single subject had documented low serum vitamin D, and every single one complained of chronic fatigue.
A textbook presentation of the silent phase.
So the researchers split them up. Half receive a placebo, the other half receives an intervention. But they don't give them a daily gummy vitamin. They administer a single, massive oral dose of 100,000 IU of vitamin D3.
To contextualize that scale, 100,000 IU is 25 times the absolute maximum safe daily limit we established earlier.
25 times.
This is a highly controlled, massive pharmacological depot dose designed to instantaneously flood the system and correct the deficiency.
They drop a nuclear payload of D3 into their systems, and then they wait. 4 weeks later, they assess the patients, the placebo group, still exhausted, still dragging themselves through the day.
And the intervention group.
The group that received that single 100,000 IU dose, their blood serum levels had skyrocketed into the optimal range, and their symptoms had vanished. The researchers explicitly concluded that the massive dose literally cured their reported fatigue in a matter of weeks.
The mechanism here is directly linked to mitochondrial function. The mitochondria are the power plants inside your cells that generate energy. Vitamin D acts directly on skeletal muscle mitochondria, enhancing their ability to produce ATP, the energy currency of the cell.
Oh.
When you replace the missing hormone, you are quite literally turning the cellular power plants back on. It implies that a vast swath of the population relying on caffeine to survive the day might just be suffering from a highly treatable endocrine deficiency.
And a highly cost-effective one to treat, as the study noted. Okay, let's transition from general fatigue into a much darker neurological space: clinical depression. The data here is robust. First, we look at a 2015 study tracking 185 female undergraduate students living in the Pacific Northwest.
A geographic region notorious for its relentless cloud cover and lack of direct sunlight during the fall, winter, and spring.
Exactly. They tracked these women for 4 weeks during the darkest parts of the year, drawing blood for serum analysis and administering rigorous psychological depression surveys. The results were alarming. Between 34 and 42% of these otherwise healthy young women reported clinically significant depressive symptoms.
Wow, that's high.
And when they cross-referenced the psychological data with the blood panels, the correlation was undeniable. The women presenting with the lowest levels of vitamin D3 had a markedly increased risk of demonstrating these depressive symptoms.
The researchers concluded that deficiency occurs at alarming rates in healthy young women, and it directly compromises their mood stability.
But the evidence isn't limited to a rainy college campus. The sources provided a mammoth 2013 systematic review and meta-analysis published in the British Journal of Psychiatry.
A meta-analysis is basically the apex of evidence-based medicine. The researchers don't just run one experiment. They gather a multitude of existing, high-quality studies and synthesize all the raw data to identify massive macro trends that a single study might miss.
In this case, they compiled data from 14 different studies, creating an immense pool of 31,424 adult participants.
The statistically unassailable sample size.
And the macro trend they found was definitive. Across tens of thousands of people, subjects diagnosed with clinical depression consistently presented with lower levels of vitamin D compared to the healthy control groups. Now, why is this happening? Why does a vitamin made in the skin affect the sadness in the brain?
It comes down to neurotransmitter synthesis. Vitamin D receptors are densely packed in the regions of the brain responsible for regulating mood, particularly the hippocampus and the hypothalamus.
Okay, what is it doing there?
The hormone is actively involved in the genetic expression of the enzyme that synthesizes serotonin, dopamine, and norepinephrine, the exact chemicals that regulate human happiness and motivation. If you starve the brain of the catalyst, the chemical production line falters.
The researchers framed this as an urgent global public health imperative. They noted that depression is the third leading cause of disability in higher income countries, impacting over 800 million people globally. And they pointed out that supplementing with D3 is an unbelievably cheap, easily deployable tool with virtually no adverse effects compared to complex psychiatric medications.
It is an upstream intervention for a downstream neurological crisis.
And speaking of neurological crises, we have to look at the aging brain. Cognitive decline and dementia. The literature highlights a 2015 population-based study from Germany tracking 1,373 older adults with an average age of 75.
Within that cohort, the clinicians identified 75 subjects suffering from mild dementia.
And when they ran the blood panels, the patients with dementia had significantly lower levels of serum vitamin D compared to their cognitively intact peers. Now, the researchers were appropriately cautious. They stated that this is an association, and further longitudinal trials are required to prove that vitamin D actively protects against the structural decay of dementia. But the correlation is a massive red flag.
And the correlation makes physiological sense. Vitamin D actually aids in the clearance of amyloid plaques, which are the toxic proteins that build up and destroy neurons in Alzheimer's disease.
But the brain benefits aren't just about preventing decay in the elderly. The sources offer a 2017 study from Canada, published in Experimental Gerontology, that flips the script. They took 82 completely healthy adults during the winter. They divided them. Half received a baseline dose of 400 IU, and half received the maximum safe limit of 4,000 IUs a day.
They maintained this protocol for 18 weeks.
And at the end of the 18 weeks, they tested their cognitive performance. The group taking the high-octane 4,000 IU dose didn't just maintain their baseline, they actually experienced measurable improvements in their nonverbal visual memory. Healthy adult brains got sharper and faster just by maximizing their hormonal intake.
It really challenges our entire definition of adequate nutrition. Are we aiming for the bare minimum to prevent disease, or are we aiming for optimal cognitive performance?
To cap off the neurological section, a 2014 study from Norway looked at psychogeriatric patients, elderly individuals institutionalized with severe psychiatric disorders. They found a staggering 71.6% of these psychiatric patients were severely deficient, compared to only 19% in the healthy control group.
The researchers posited that this chronic deficiency might not just be a byproduct of being indoors. It might actively be exacerbating or even contributing to the underlying psychiatric pathology.
The brain is screaming for regulatory support. Let's move down the body, out of the brain, and into the metabolic engine room. Metabolic and gut health.
The metabolic implications are severe. We reference the 2012 OSTIAB study, which is the Australian Diabetes, Obesity, and Lifestyle Study. This is a massive longitudinal effort. They tracked 4,164 adults who were completely metabolically healthy at the start of the study.
No diabetes, no cardiovascular issues.
None. They tracked them for 5 years. During that half-decade, 528 of those previously healthy individuals developed metabolic syndrome.
Which is that dangerous cluster of conditions: abdominal obesity, insulin resistance, elevated blood pressure, and high triglycerides. It's the launch pad for a massive heart attack.
When the researchers analyzed the blood data of the 528 people who got sick, they found a chilling statistic. Subjects who entered the study with low levels of vitamin D had up to a 74% increased rate of developing metabolic syndrome over those 5 years.
Wait, a 74% increased risk? How is a vitamin linked to insulin and belly fat?
It revolves around the pancreas and insulin sensitivity. The beta cells in the pancreas, which produce insulin, are lined with vitamin D receptors. The hormone is required for the pancreas to release insulin efficiently.
Okay.
Furthermore, it regulates how effectively your muscle and fat cells respond to that insulin. When vitamin D drops, the cells become insulin resistant, glucose builds up in the blood, and the body aggressively stores it as visceral belly fat.
The entire metabolic engine gets flooded and stalls. This ties perfectly into the obesity data we reviewed earlier. The 2017 French study of 564 severely or morbidly obese adults showed that 543 of them, almost the entire cohort, were deficient.
Only 21 out of 564 possessed normal levels. The adipose tissue sponge effect in undeniable action.
Let's follow this pathway straight into the digestive tract itself, the gut microbiome and the intestinal lining. There is a deeply fascinating link to irritable bowel syndrome, or IBS. A 2015 UK pilot study looked at 51 patients suffering from the chronic pain and altered motility of IBS.
The baseline blood test revealed that between 70 and 80% of these IBS sufferers were highly deficient in vitamin D.
Wow, 80%.
Yeah, and the researchers initiated a 12-week supplementation protocol, which successfully elevated their serum levels. While it was a small pilot study necessitating larger trials, the near-universal presence of deficiency in an inflamed gut is a vital clue.
But I want to push back on the expectation here, because the gut connection gets much heavier when we transition from IBS to inflammatory bowel disease, IBD, like Crohn's or ulcerative colitis. If a patient with severe IBD takes a vitamin D pill, does it cure the disease?
No, it does not cure the autoimmune pathology of IBD. but it dictates whether the medical treatment will actually work. Yes. A critical 2017 study from Brigham and Women's Hospital in Boston looked at 173 IBD patients who were initiating complex medical therapies.
They were starting the heavy-duty pharmaceuticals.
Yes. The researchers discovered that patients who presented with low levels of vitamin D at the commencement of their treatment had drastically decreased odds of the therapy actually achieving clinical remission.
The lack of the vitamin physically blocked the medicine from doing its job. Why?
Because vitamin D is instrumental in maintaining the integrity of the tight junctions in the intestinal lining. It acts as the mortar between the bricks of your gut wall.
Okay, I can picture that.
In IBD, that wall is degraded, allowing pathogens to leak into the bloodstream and trigger massive autoimmune inflammation. If you don't have vitamin D to help rebuild the physical barrier, the anti-inflammatory drugs are fighting a losing battle. The foundation is cracked.
You cannot build a healthy gut without the raw materials to seal the lining. Okay, we've navigated the brain, the metabolism, and the gut. Now we pivot to a demographic where the stakes are arguably the highest: childhood development and bone health. We briefly touched on rickets, but the modern data reveals a much more insidious epidemic among children.
Let's examine the intersection of childhood and metabolic dysfunction. A 2013 study published in Pediatrics analyzed an enormous data set of over 12,000 children across the United States.
12,292 kids. And they uncovered a grim, mathematically precise staircase effect linking their weight to their hormonal depletion.
As the body mass index climbed, the serum levels collapsed. The deficiency rate was 21% for healthy weight children. It climbed to 29% for overweight children, hit 34% for obese children, and peaked at a devastating 49% for severely obese children.
Half of the heaviest kids in the country are starving for this hormone. But the researchers didn't stop at weight. They stratified the data by race, and the numbers became genuinely horrifying.
This is where the biology of melanin and the pathology of obesity collide. Among the severely obese white children, 27% were severely deficient. For severely obese Latino children, that figure surged past 50%.
And African-American children.
For severely obese African-American children, the severe deficiency rate approached 90%.
9 out of 10 severely obese African-American kids in that cohort were operating with fundamentally depleted regulatory systems. The researchers urgently demanded that pediatricians institute aggressive, targeted screening for minority and obese children. It is a massive, life-altering blind spot in pediatric care.
And it is a fallacy to assume that thin, healthy-looking children are automatically safe. A 2016 study from Norway evaluated a cohort of completely average, healthy 6 to 8-year-old children. They exhaustively tracked their dietary intake and measured their blood levels.
The findings: almost every single child in the study was taking insufficient amounts.
The primary takeaway from the Norwegian study was a massive failure in dietary strategy. The researchers found that relying on fortified foods is woefully inadequate. In this specific group, the primary dietary source of the vitamin was artificially fortified milk. Natural, unfortified foods only accounted for 20% of their intake.
The math is brutal. If a kid isn't aggressively chugging fortified milk or eating highly specific fatty marine fish, they are mathematically guaranteed to fall short. And the biological demand only escalates as they age.
The transition into adolescence triggers a period of explosive, rapid skeletal growth. A 2016 UK study focusing on teenagers aged 14 to 18 determined that simply to maintain adequate serum levels while their bones are lengthening and densifying, teens require a daily intake of between 10 and 30 micrograms.
Which translates to roughly 400 to 1200 IU every single day. They are burning through the hormone just to construct their adult skeleton. Now, hearing all this, a highly proactive parent might think, I'm going to hack the system. My kid is healthy, but I'm going to pump them full of maximum dose vitamin D supplements so they build indestructible superhuman bones.
Which brings us to a vital caveat in the literature. You cannot hack the biological maximum.
So no superhuman bone?
No. A 2011 systematic review and meta-analysis from Australia analyzed 6 distinct clinical trials involving healthy children and adolescents who already possessed normal, optimal baseline levels of vitamin D.
Their tanks were already full.
Despite having full tanks, the researchers administered varying protocols of supplementation, ranging from moderate daily doses all the way up to massive 14,000 IU weekly blasts for a duration of at least 3 months.
Did the extra fuel make the engine run faster? Did their bones get denser?
No. The overall findings conclusively demonstrated that the excess supplementation yielded no statistically significant improvement in the bone mineral density of the hip, the forearm, or the total body skeleton.
The lock and key system has a maximum capacity. Once all the calcium doors in the gut are unlocked, throwing thousands of extra keys into the bloodstream achieves absolutely nothing. The goal is to correct a deficiency, not to arbitrarily flood a healthy system.
Precisely. Which brings us to our final and perhaps most consequential category of clinical research: immune and systemic diseases. This is where we trace the long-term delayed fuse consequences of the childhood deficiencies we just discussed.
Let's look at the immune system's memory. A 2017 Australian study tracked 263 children from the moment of birth all the way to their 10th birthday. They meticulously documented their vitamin D levels and their medical histories.
They found that children who suffered from repeated bouts of deficiency during their earliest developmental years, the toddler phase, experienced a vastly heightened risk for severe acute respiratory tract infections.
But the damage didn't end with a bad cough. Those early repeated infections cascaded. The researchers found that the early deficiency directly paved the way for a heightened risk of developing chronic asthma, hay fever, and eczema by the time the child turned 10.
The mechanism here involves the programming of T regulatory cells. During infancy, the immune system is learning how to identify threats. Vitamin D is required to train the immune system to tolerate harmless environmental proteins like pollen or dust mites.
Right.
When the hormone is absent, the immune system develops improperly. It becomes hyperreactive, resulting in lifelong allergic and asthmatic conditions. You're programming an overactive defense.
Reframes how we view human development is this 2015 cardiovascular study conducted jointly by researchers in Finland and Australia.
It is a masterclass in longitudinal epidemiology. The researchers enrolled 2,148 Finnish children, ranging in age from 3 to 18 years old. They drew their blood, measured their vitamin D levels, and recorded the data.
And then they waited. They didn't check back in a year or two. They waited 27 years.
Almost 3 decades later, they tracked down the subjects, who were now adults between 30 and 45 years old. The clinicians used high-resolution ultrasounds to physically measure the thickness of their carotid arteries.
The carotid intima media thickness. It is the primary diagnostic indicator for subclinical atherosclerosis, the silent, symptomless hardening and narrowing of the arterial walls that eventually culminates in a heart attack or stroke.
The discovery was profound. The subjects who had the lowest 25% of vitamin D levels when they were children, 3 decades earlier, demonstrated a significantly higher risk for thickened, hardened arteries as adults.
And the researchers controlled for other variables, right? This wasn't just because they grew up to be smokers.
Correct. The increased risk was entirely independent of adult smoking habits, adult blood pressure, or adult cholesterol levels. The physiological damage to the endothelial cells lining the blood vessels was locked in during their childhood.
But here is the most crucial part of this study. They also measured the vitamin D levels of the subjects as adults when they did the ultrasounds. And the adult levels had zero association with the arterial hardening.
That is the pivotal insight. If you are a 35-year-old adult and your vitamin D drops for a few years because you started an office job, your arteries don't instantly calcify.
Wow.
But if your levels are severely depleted during the critical developmental window of childhood, while the vascular system is actually being constructed, the architectural flaw becomes permanent. You carry the cardiovascular scar tissue for the rest of your life.
The blueprint was drawn with missing ink. It is absolutely terrifying, but it's also the ultimate empowering knowledge for a parent. Okay, we have one final study to round out our research deep dive, and this one pushes the developmental window back even further, all the way into the womb.
We are looking at the 2016 Generation R study based in Rotterdam, the Netherlands. This is a massive, population-based prospective cohort designed to track maternal and fetal health. They collected exhaustive data on over 4,200 pregnant mothers and their subsequent children.
The researchers were hunting for maternal metabolic factors that might correlate with the development of autism spectrum disorders in the child.
They drew blood from the mothers during mid-gestation, the precise middle of the pregnancy, when fetal brain development is exploding. Years later, when those children reached age 6, the parents completed rigorously validated psychological questionnaires to identify autistic traits.
And the biochemical link was there?
It was highly significant. The mothers who were clinically deficient in vitamin D during that critical mid-gestation window were significantly more likely to give birth to children who later developed autism spectrum disorders.
How does a vitamin in the mother's blood affect the neural wiring of the fetus?
Calcitriol, the active hormone, crosses the placenta and is absolutely crucial for fetal neurogenesis. the actual birth and migration of neurons in the developing brain. It regulates the growth factors that tell the brain cells where to go and how to connect. In its absence, the intricate neural architecture is disrupted.
The researchers concluded with a profound statement. They pointed out that because gestational vitamin D deficiency is so incredibly easy to prevent with cheap, safe, over-the-counter supplements, this demands immediate, intense scrutiny as a controllable risk factor in prenatal care.
We have journeyed from the moment of fetal neurogenesis through the arterial development of childhood, past the hormonal turbulence of adolescence, into the gut and metabolic stability of adulthood, and finally into the cognitive preservation of old age.
It literally touches every single phase of human existence. It is the master regulator. So, having reviewed this overwhelming mountain of clinical benefits, a very logical, very dangerous thought process emerges. If this molecule cures fatigue, wards off depression, seals my gut, and keeps my heart ticking, shouldn't I just go buy the biggest bottle of supplements I can find and swallow a handful right now to saturate my system?
I am issuing an absolute uncompromising hard stop on that logic.
Great, lay out the pathology for us. Why can't I just flood the engine?
Because you cross the threshold into vitamin D toxicity. Now, we established earlier, and it bears repeating, it is physiologically impossible to achieve toxic levels through natural sun exposure or through dietary intake of salmon and eggs. The evolutionary factory has a failsafe.
I can't overdose lying on a beach.
No. The only mechanism for inducing toxicity is bypassing the skin's regulatory system and swallowing grossly excessive amounts of concentrated oral supplements over a prolonged period.
Force feeding the gut.
Exactly. When you intentionally overdose on supplements, you force an unmanageable volume of the active hormone into the bloodstream. And you have to remember, its primary mechanical function, the regulation of calcium.
It's the key that unlocks the door in the intestines to let the dietary calcium into the blood.
Right. Now imagine you have swallowed tens of thousands of extra keys. You violently unlock every single calcium channel in the gut. The body absorbs massive, unnatural quantities of calcium from your diet and aggressively dumps it directly into your bloodstream. This creates a severe metabolic crisis called hypercalcemia.
Hyper meaning excess, calcemia meaning calcium in the blood. Now, intuitively, someone might think, great, extra calcium means I'll have bones made of steel. But that's a fundamental misunderstanding of the pathology.
It is the exact opposite of healthy. Massive concentrations of blood calcium are highly toxic to the soft tissues. The calcium begins to crystallize and deposit in the kidneys, the heart, and the lungs. It disrupts the electrical signaling of the nervous system.
What does that actually feel like to the patient?
The clinical presentation includes intense, debilitating nausea, severe vomiting, profound cognitive confusion, and deep systemic fatigue.
Which is the ultimate cruel biological irony. You take massive doses of the supplement to cure your fatigue, and you overdose yourself right back into total exhaustion.
It is a complete metabolic overload. Fortunately, the sources note that because toxicity is entirely self-inflicted via supplementation, the medical fix is straightforward. The symptoms improve rapidly when the patient simply stops taking the massive doses and the serum levels are allowed to drastically reduce. It remains a rare clinical condition, but it is a vital warning against the more is always better mentality.
Balance is the absolute key. We want the cellular receptors activated, but we do not want to flood the engine room. We've mapped the biochemistry, we've broken down the clinical trials, and we've explored the pathologies. Now here's where it gets incredibly interesting for your actual daily routine. We are going to distill everything we've just discussed into a rapid-fire sequence of actionable, practical takeaways. 10 rules derived strictly from the scientific literature.
I will begin with the most biologically appropriate directive. Number 1. Prioritize safe, deliberate sun exposure. Utilize your body's built-in evolutionary factory. Give your bare skin the UVB raw materials it needs when the season, the weather, and your geography actually permit it.
Number 2. When winter hits and nature isn't cooperating and you need a supplement, do not grab the first bottle you see. Read the label. Opt for vitamin D3 or cholecalciferol over D2. It is the native software code for your body. It will raise your active blood levels far more efficiently.
Number 3. Adjust your dietary patterns to incorporate the ocean's bounty. Prioritize fatty marine fish like salmon, sardines, and tuna. They provide the vitamin perfectly prepackaged in the exact lipid delivery system your gut needs to absorb it.
Number 4, if you absolutely despise the taste of fish, leverage modern food science. Check your groceries for the fortified label on milk, breakfast cereals, and orange juices to ensure a steady baseline intake.
Number 5. Acknowledge the biological reality of aging. The skin's manufacturing capacity degrades over time. If you cross the age of 70, you must proactively bump your baseline daily intake up to 800 IU.
Number 6, protect the structural development of the babies. Exclusively breastfed infants require proactive liquid supplementation of 400 IU daily to prevent the catastrophic bone bending of rickets.
Number 7, be aggressively proactive if you possess dark skin. Melanin is a brilliant evolutionary defense against UV radiation, but it fundamentally impairs your ability to synthesize the hormone. You cannot rely on casual sunlight. You must aggressively manage your dietary and supplemental intake.
Number 8, monitor your metabolic state. If you are overweight or clinically obese, remember the sponge mechanism. The excess adipose tissue chemically binds and traps the vitamin, keeping it locked away from your bloodstream. You might be swallowing enough, but your cells are still starving.
Number 9, and the absolute paramount rule of safety. Never exceed the upper limit of 4,000 IU daily without direct, supervised medical guidance. Bypassing this ceiling with synthetic pills is the sole pathway to inducing hypercalcemia and toxic organ calcification.
And finally, number 10, think in terms of decades for your children. Ensure your kids maintain adequate levels during their early developmental windows. The clinical data proves that early childhood deficiency permanently scars the vascular system and programs the immune system for future cardiovascular disease, severe asthma, and lifelong allergies.
That is a rigorous, highly actionable set of parameters derived directly from the evidence.
Now, before we close the book on this deep dive, we need to do a little intellectual housekeeping. When navigating a topic this dense, there is an enormous amount of pseudoscientific noise floating around the internet. Let's clear away the confusion. Let's run a quick, definitive round of myths versus facts.
Let's correct the record.
Myth number 1. If I spend 8 hours working outside in the blistering summer sun without a shirt on, I am going to experience vitamin D toxicity and poison my organs.
Fact. That is biologically impossible. The skin possesses a flawless autoregulatory mechanism. Once the optimal level of pre-vitamin D is synthesized, the ongoing UVB radiation physically destroys the excess. Toxicity is exclusively achieved by swallowing an excessive amount of supplement pills.
Myth number 2. My teenager is perfectly healthy. Their blood tests show normal vitamin D levels, but I should force them to take a daily supplement anyway so they develop superhuman, hyperdense bones for athletics.
Fact. Demonstrably false. The 2011 Australian meta-analysis definitively proved that administering extra supplements to healthy children who already possess normal optimal levels offers absolutely zero additional benefit to their bone mineral density. You cannot hack the biological maximum.
Myth number 3. I live in a dark, freezing northern climate, so buying a membership to an indoor tanning salon for the winter is a brilliant biohack to keep my hormonal factory running smoothly.
Fact. Absolutely, unequivocally not. The dermatological literature is unanimous. While tanning beds do emit the necessary UV rays, they simultaneously bombard the skin with a highly concentrated spectrum of radiation that exponentially increases the risk of malignant melanoma and skin cancer. The lethal risk completely eclipses the nutritional benefit. They must be avoided entirely.
And myth number 4. As long as my kid eats a generally normal, modern diet, they are guaranteed to be getting enough vitamin D from their food.
Fact. Highly improbable. The 2016 Norwegian dietary study highlighted that a mere 20% of a child's intake comes from natural, unfortified food sources. Unless your child is consistently consuming specifically fortified milk or aggressively eating fatty marine fish, they're statistically highly vulnerable to deficiency.
So, discard the myths. Adhere strictly to the physiological facts. As we bring this massive deep dive in for a landing, how would you synthesize the ultimate overarching truth about this molecule based on the absolute mountain of sources we just unpacked?
If I am forced to distill this entire complex network of endocrinology, neurology, and immunology into a single cohesive thesis, it is this. We must fundamentally discard the idea of vitamin D as merely a nutrient for your bones. That definition is not just outdated, it is medically dangerous in its narrowness. It is, in clinical reality, a vital full-body regulatory steroid hormone. It is the molecular architect of your skeletal framework, the stabilizer of your gut microbiome, the programmer of your immune defense, and the chemical guardian of your cardiovascular and cognitive longevity. It is remarkably inexpensive and easy to safely supplement, and as the decades of clinical trials clearly demonstrate, it is utterly catastrophic to ignore.
It is the biological linchpin for human health. And as we conclude today, I want to leave you, the listener, with a final provocative thought to turn over in your mind, something that builds upon the foundational biology we discussed today.
What is the realization?
We spent this entire time marveling at the fact that the human body evolved over millions of years a highly sophisticated mechanism to manufacture a crucial life-sustaining hormone directly from the sun. It is woven into our very DNA that we require a physical solar connection to function properly. So, looking at the modern landscape of health, how much of our skyrocketing chronic disease, the pervasive baseline fatigue, the clinical depression, the autoimmune degradation of the gut, the epidemic of metabolic syndrome, is simply the inevitable biological consequence of humanity deciding to live indoors?
It frames modern illness as a profound evolutionary mismatch.
Exactly. If the architectural design of our cities, our screen-based technological hobbies, and our rigid indoor corporate work schedules literally physically separate us from our most vital natural evolutionary catalyst, are we just endlessly treating the downstream symptoms of modern life with expensive pills and complex prescriptions rather than fixing the fundamental flaw in how we live?
He suggests that stepping out into the sunlight isn't just a pleasant break for fresh air. It is a non-negotiable requirement for cellular stability.
It really is. When you
Yeah.
step back into that murky, confusing diagnostic landscape we talked about at the very beginning, where symptoms are vague, where the fatigue is unexplainable, and where the chronic issues are hard to pin down, maybe the very first thing we should look for isn't a jagged line on a high-tech X-ray or a new pharmaceutical drug. Maybe the very first thing we should do is look up at the sky and honestly ask ourselves how long it has been since we actually felt the sun on our skin. Thank you for joining us on this deep dive. Take care of your internal factories, read your supplement labels carefully, and seriously, go outside.